Hey there, here is your review video for topic 7.7, which is acid deposition. As I get this loaded, that's really the first thing I wanted to talk about, was to understand why it is we're using that word deposition. It is because it's not just that this particular type of secondary pollutant isn't just rain. It can fall as a aerosol particles that contain a solid salt. It can also be in a gaseous form. All right, so remember, acid deposition is a secondary pollutant, which means you need to know what its primary pollutants are and then also where those primary pollutants come from. The first set of primary pollutants is nitrogen oxides. Notice we're not calling it NOx because you have this N2O here as well. NO and NO2 together is NOx. And then sulfur oxides, sometimes you can get SO, but frankly, if you stick to SO2, that is hands down the most common form. The reason that we include NO and NO2 together is a lot of times those two chemicals will cycle back and forth between each other. All right, natural sources of these are going to be lightning and microbes. Remember, during the nitrogen cycle, a lightning strike can convert atmospheric nitrogen, which is N2, and atmospheric oxygen, which is O2, into ammonium ions. And it does that through a cascade of steps that includes a bunch of this stuff here. And then microbes also during the denitrification process, where it takes ions that are in the soil and then converts them back into atmospheric nitrogen and atmospheric oxygen, can also go through those compounds as well. Natural sources of sulfur oxides is just straight up volcanoes. All right, anthropogenic, which means human-made. Remember that the main source of nitrogen, of NOx type compounds, is going to be motor vehicles burning the fossil fuel gasoline that comes from petroleum. So yes, sometimes you see nitrogen as a impurity in coal burning power plants, but not often. Now, the reason N2O is in here is that is a byproduct of, not of artificial fertilizer, but of the breakdown of artificial fertilizer. Remember, N2O is a gas, so that you're not buying it in a bag, all right? The artificial fertilizer is a solid. As the fertilizer breaks down, it can release N2O as a gas. And then you also, sulfur is the main impurity in coal. So when you have coal burning power plants that don't have scrubbers in place, it's going to release a lot of that SO2. All right. Please be aware that NOx and N2O produce nitric acid, which is HNO3, and then SO and SO2 produce sulfuric acid, which is H2SO4. So don't be talking about cars and then all of a sudden talk about sulfuric acid, because you are not magic. All right, but what is this diagram telling you? It is telling you that these primary pollutants combine with water vapor in the air, it kind of left that part out, to make the secondary pollutants of acid deposition. What is this trying to tell you? Especially since you have an ocean here, ocean breezes blow from the ocean to the land, so the wind here is going to be moving from left to right. So that means that the primary pollutant that is released by this industry here becomes a secondary pollutant, acid deposition, that ends up falling here in a more rural area. Why is that an issue? Acid deposition, among other things, reduces the productivity of plants, and if this is where we're growing our food, that's a problem. And then also, this is where you can have bodies of fresh water that provide drinking water, or also places where you have fish, which is also a food source. All right, what are the harmful impacts? You need to make sure you get all of this stuff. So let's talk about nature first. First, you just have the straight up changing of the pH of either soil or water. Remember, that means the pH number is going to get lower. Not when something becomes more acidic, the number doesn't go up, it goes down. Remember, acids go from 7 to 0. So you're going to have a decrease in that number. This can just straight up put the range of the acidity of the soil or the water beyond the range of tolerance of these plants, which means that they die. Basically, it doesn't work for their physiology, for their systems. Please, again, realize these things are not dying because they get hit with acid and melt. That's not how it works. All right, another thing that can happen is what's called the mobilization of ions. Acids take solids, especially metals, and make them into ions. Remember, ions only exist in water, and then when they're in water, they go wherever the water goes. So let's talk about the two kinds of ions that this can mobilize in soil. The first kind of ions are going to be things that are not nutrition. So it's going to be things like aluminum ions and zinc ions and mercury ions and lead ions and cadmium ions. Mercury, lead, and cadmium are heavy metals, so that means that if they are taken up by the plant and bioaccumulated in the plant, they can again overwhelm the plant's systems and kill it through its rising toxicity. Remember, when you bioaccumulate, something that is just a little dose every day becomes a big dose as it builds up. If that runs into the water, same deal. It can bioaccumulate in little fish, killing them, but then also it can biomagnify as you move up the food chain, also killing apex predators. Talk about ions like aluminum and zinc. Those are ions that irritate the gills of fish, meaning that they overproduce mucus, which means fish can basically drown in their own spit and die. So basically we've identified 3 reasons so far as to how these guys end up dead. And then lastly, you have the mobilization of nutrition ions, things like calcium and magnesium that plants need to grow. So if you take them and then all of a sudden you dissolve all of them, and there's a lot of water flow from rain or irrigation, it means that those nutrition ions like calcium and magnesium, potassium, can wash away elsewhere, leaving the plants to starve, or they percolate down into the subsoil where the roots can't get, also meaning that they starve. So again, acid rain is not falling on this and causing the leaves to fall off. These things are starving to death. All right, what about human-made structures? So you have corrosion of stone. There are statues that have stood the test of time over thousands of years that started to basically melt away during the Industrial Revolution because of acid deposition. Statues at the Acropolis in Greece that predate the birth of Christ by thousands of years had to be brought indoors because of the impact that acid deposition was having on them. So this is literally erasing our human history. Why are these things so susceptible? Because they're oftentimes made out of marble, and marble is a metamorphic rock with its origins in limestone, and limestone is a base that reacts very readily. That means it's a spontaneous reaction with acid deposition, creating a salt in a water during that neutralization process, washing the stuff away. Also remember that acids can corrode metals, copper, zinc, any structure that's outside that's made of metal can also be corroded by acid. All right, what does acid rain do to your body? I'll post this link, but just realize that it's an air pollutant, so upper respiratory irritation, leading you more susceptible to secondary infections like pneumonia. It aggravates asthma and bronchitis. And then also, this is an acid, so it can permanently scar your lungs, decreasing your lung function, making things like strokes and heart attacks more prevalent. Plus, you're also not getting enough oxygen, so it kind of impairs your ability to think and stuff like that. All right, so what is this slide all about? Remember we talked about the limestone that can be worn away by acid rain? Well, if you crush it up and sprinkle it where there is acid deposition, you can neutralize it into things that are not harmful, salts and water. So if you have soil that already has a high level of stuff like limestone in it, which is calcium carbonate, CaCO3, that means that it is a buffer. A buffer is something that can take a certain amount of acid without the pH of the soil changing. It, because of an equilibrium situation that you don't need to know about, you can say it's a buffer. It neutralizes the acid, creating salt and water. What this also means is in places where you already have acid deposition, killing trees or acidifying lakes and rivers, is you can actually literally sprinkle this stuff on there like an antacid, neutralizing it and bringing the ecosystem back to its normal pH levels. So in cases where, let's go back, where let's say this is happening in another country, you can't force them to create laws to stop what they're doing. You can't force them to use scrubbers. What this means is that you can mitigate what's going on. You can reduce the impact that it has where you are. Always, it is less expensive to prevent pollution than it is to clean it up, but sometimes cleanup is your only choice. So here's a little success story here. And here is one more look at the whole acid deposition of it all. Here too, also remember that if the acidity itself doesn't end up in streams and harming trees, it can also end up in your groundwater for you to drink. If you remember the story of Flint, Michigan, the reason that they had problems were not because of lead in the water, the water source, or because of the lead pipes by themselves. It's because the change in source meant it was a more acidic water that then stripped the protective coating out of the inside of those lead pipes, which then allowed the water to go ahead and strip lead ions out of the solid lead, which then resulted in higher lead levels in the water. So even just having acidic water to drink, if it's running through lead pipes, that's also problematic. Remember that lead concentrates in fatty tissues like the brain and can lead to permanent learning deficiencies, developmental delays, damages to your nervous system. These things are permanent. And here again you can see the mobilization of those ions from one place to the next, all under the action of that H+ ion. That's what makes an acid an acid. All right, and we're done.